Hello friends, today we are going to see the part 4 of antihyperlipidemic agents. In the fourth part, we are going to cover about the SAR and commercially available HMG-RIs drugs. In the part 3, part 2 and part 1, we have covered biosynthesis of cholesterol degradation pathway, then classification of antihyperlipidemic agents, as well as inhibition of HMG-CoA reductase enzyme. This main part we have covered. Now today we are going to see very important part, that is the SAR of HMG-RIs. So first of all, we will see the structure of all HMG-CoA. These are all these structures or all these drugs are available commercially. So in the first structure, lovastatin and simvastatin. Here we are seeing R group. This R groups here, if H is present, then these are called as lovastatin, and if CH3 is present over here, then it is called as simvastatin. And if you will see this ring here, this is the lactone ring present. Then pravastatin. So in the pravastatin, bicyclic group is still present. This lactone ring is opened. Here dihydroxycarboxylic acid is formed. So here dihydroxycarboxylic acid is very important for the activity. Then bicyclic ring is present and ethylene bridge is present. So mostly alteration over here can give the different new drugs. This is the structure of fluvastatin. This is atorvastatin, pivastatin and rosuvastatin. So in all the structures here, dihydroxycarboxylic acid or carboxylic acid salts are responsible for the inhibition activity of HMG-CoA. These are the structures where we have shown the open lactone ring, and here this is the open dihydroxycarboxylic acid ring. Mostly wherever the lactone rings are present, so at that situation they are called as mostly as prodrug, and this prodrugs goes into the liver and convert or hydrolyze to form the active form of the statins. These are some pharmacokinetic parameters of HMG-CoA reductase or statins, such as atorvastatin, fluvastatin, lovastatin, pravastatin, pivastatin, rosuvastatin and simvastatin. So here log P value, oral bioavailability, active metabolite, protein binding, time to peak concentration, elimination half-life and major route of elimination, all these are mentioned of all these statins. Now, as initially the statins were discovered, that is the mevastatin was discovered and lovastatin was discovered from the natural sources or fungal sources. So initially whenever they obtained, they was having the lactone ring. So in vivo hydrolysis of this lactone ring happened to form dihydroxy acid, which is the open ring, and this ring is mostly responsible for the activity. So after opening the ring and forming open ring in the liver, this structure competitively inhibit the HMG-CoA with the HMG-CoA reductase enzyme and stop the formation of mevalonic acid. This is the mechanism we have seen earlier. Now we are going to see in detail about the SAR. In the SAR, mostly this bicyclic ring, ethylene bridge as well as lactone ring. Here the alteration in all these three happens to form a new drugs or active moiety. So this is the SAR. Here mevastatin and lovastatin serve as lead compound in the development of additional HMG-RIs. HMG-RIs is the HMG reductase inhibitors are called as the HMG-RIs. Alteration of the lactone and bicyclic ring as well as ethylene bridge between them leads to new HMG-RIs. The result demonstrated that the activity of this HMG-RIs is sensitive to the stereochemistry of lactone ring. the ability of lactone ring to be hydrolyzed, and the length of bridge connecting the two ring system, that is the ethylene bridge. Bicyclic ring could be replaced with other lipophilic rings, and that are the size and shape of this other ring system were important for the overall activity of compound. As here we have seen, bicyclic ring, lactone ring as well as ethylene bridge are important for the activity. If we are going to replace the bicyclic ring, so other ring should have the lipophilic in nature, and it should have shape and size which will be responsible for overall activity of the compound. Minor modification of bicyclic ring and side chain ester of lovastatin produces simvastatin and pravastatin. Pravastatin, a open ring dihydroxy acid with alpha hydroxy group, is much more hydrophilic than that of lovastatin and simvastatin, and that's why it is more active in nature. Enhanced hydrophilicity are minimal penetration into the lipophilic membranes of peripheral cells for better selectivity of the hepatic tissue and reduction in the incidence of side effect seen over the lovastatin and simvastatin. Hence, if the hydrophilicity increases, it increases its activity and side effect also decreases. The replacement of bicyclic ring with various substituted aromatic ring system lead to development of atorvastatin, fluvastatin, pivastatin and rosuvastatin. Here two structures are mentioned, compound A and compound B. So here these two structures are also responsible for HMG-RI's activity. So what happen if we change this structure? The initial rationale centered on a desire to simplify the structure of myostatin and lovastatin. The 2,4-dichlorophenyl analog compound A was one of the first compound to demonstrate this type of substitution was possible. However, compound A was considerably less potent than the myostatin. So here insertion of this, instead of bicyclic ring, here 2,4-dichlo ring is inserted, and it shows the decrease in potency than as compared to myostatin. Subsequent research investigated a variety of aromatic substitution and heterocyclic ring system to optimize HMG-RIs. The substituted pyrrole ring in compound B retained 30% of the activity of myostatin, was a key intermediate in the development of atorvastatin. So hence in the compound B, here instead of bicyclic ring, this ring was inserted, and this ring was responsible for the activity of or development of atorvastatin, but the ring is showing that 30% of the activity as that of myostatin. So inserted pyrrole ring, it shows little activity as compared to this dicyclo ring, and this is development for atorvastatin synthesis, where this lactone ring and bridge, this ethylene bridge is common in both structure. Only change in the bicyclic ring happens to form or in search of new compounds. The 4-fluorophenyl and isopropyl or cyclopropene substitutions found in compound B were also seen in the indole, quinoline and pyrimidine ring system of lovastatin, pivastatin, rosuvastatin respectively, and most likely represent the optimal substitution of their respective positions. Now here we have seen the SAR activity. Here also the SAR activity of the three parts. This is the first, open lactone ring is present. This is the bicyclic ring is present, and if the changes happen in the bicyclic ring or substitution in the bicyclic ring, then the alteration in structure or activity of the drug happens is represented over here as a SAR. So we are going to see the common SAR here. If the 3,5-dihydroxycarboxylate is essential for inhibitory activity, means 3 and 5th position dihydroxy group and carboxylic acid group is essential for the antihyperlipidemic activity. Compound containing lactone are pro-drug requiring in vivo hydrolysis. So wherever the lactones are present, it has the pro-drug activity, means it activate in the liver after hydrolysis. The absolute stereochemistry of 3 and 5 hydroxyl group must be same as that found in mevastatin and lovastatin. The altering 2 carbon distance between C5 and ring system diminishes or fails to improve the activity. So here C6 and C7 carbons are present. This indicates the ethylene bridge. If we are increasing or decreasing this distance, so it decreases or fails to improve the activity. The double bond between C6 and C7 can either increase or decrease activity. The ethylene group provide optimal activity for the compound containing ring A and some heterocyclic ring. The ethylene group is optimal for compound with other ring, include indole, quinoline, pyrimidine rings seen in the fluvastatin, pivastatin, rosuvastatin respectively. Then ring subclass A. So here changes over here is happen, and what the result is happening we will see. The decalin ring is essential for anchoring the compound to the enzyme active site. Replacement with the cyclohexane ring result in 10,000 times decrease in activity. So if we are changing this ring, so decrease in activity happens. Stereochemistry of ester site change is not important for the activity. However, conversion of this ester to another ester result in decrease in activity. Methyl substitution at R position, R2 position. This is the R2 position. So here methyl substitution at R2 position increases the activity. Here if we are increasing the methyl substitution, it increases. Example is the simvastatin is more potent than lovastatin. Here the lovastatin H is present, in the simvastatin CH3 is present. The beta hydroxy group substitution at R1 position gives enhanced hydrophilicity and may provide cellular specificity. So here in the R1 group, if hydrophilicity is increased, so it increases the intracellular activity. Now we will see ring B changes. Substituents W, X, Y and Z can either carbon or nitrogen and equal to 0 or 1. That is the 5 or 6 member heterocyclic ring. The parafluorophenyl cannot be coplanar with the central aromatic ring. The R substitution with the aryl group, hydrocarbon side chain, amide or sulfonamide enhances lipophilicity and inhibitory activity. So all this about the SAR of HMG CoA reductase inhibitors. Now dosing information. So all these drugs are available in the market and brand names are also mentioned. Dosing range, maximum daily dose as well as tablet strains are mentioned over here. And all these are the commercially active drugs are present, such as atorvastatin, fluvastatin, lovastatin, pivastatin, pravastatin, rosuvastatin, simvastatin. So these are the most available commercial drugs available in the market, and all these are very effective statins are and used for lowering the cholesterol level. So we are seeing the SAR over here. Thank you so much.